Should we start?
Thomas, can you hear us?
All right, let us begin. Hello, everyone. Welcome to the very first SEAT working group meeting. Before we begin, I know that, well, this is not the first, can I have the clicker, please? This is not the first meeting of this IETF session, but still we need to go through Note well. A few most important points about Note well. First, we are expected to behave in professional manner. In my experience at IETF, topics related to TLS cryptography can cause some heated discussions. That's okay, but we need to stay professional and discuss and challenge ideas rather than individuals. So we will be moderating conversations to make sure we stay professional. If you're aware of any IETF contribution that is covered by patents, you do need to disclose that or not participate in that conversation. Yeah, we do take everything that is discussed in this meeting is treated as IETF contribution, so be aware of that. With that, this is our agenda for today. So we will have short introduction from the chairs, then Ionut will remotely join us and talk about use cases draft that he and few co-authors put together. Then Usama will present design space for attested TLS protocols and insights from formal analysis. Then Yaron will present remote attestation with exported authenticators draft on behalf of co-authors. And finally, Ionut will share with us hackathon project results. There was a hackathon session dedicated for exported authenticators. Any agenda bashing? Any concerns about agenda? Nope. Great. Okay, so let's move on. Well, first of all, we are a working group now. Thanks everyone who contributed both efforts. It was not the easiest process, but now we need to begin the real work, assemble this seat, so to speak, and get the work done. Let's begin with introduction of the chairs. Nancy, do you want to start?
Sure. Hi, everyone. For those who don't know me, I have been a strong security advocate, I guess, in the digital communication space for quite a while. In the IETF, I've done contributions in several working groups, as you can see there. I'm currently very active, mostly in the identity authorization space, and I dabble in the industrial IoT side for security. So I am a Cisco fellow. My roots in the security space are more in the key management, authentication, authorization. It's all about trustworthiness, which is I helped kickstart RATS. I didn't take credit in my contributions there, but I did kickstart that group. And again, it's all to boost the trustworthiness of the system. And I'm working on how we leverage analytics for security. Currently, I'm also, besides partnering with Yaroslav here in SEAT, I'm also co-chairing SCIM. So that's a little bit about me.
And for those who don't know me, I'm Yaroslav Rosomacho. I am a researcher at Zscaler. I'm active primarily in transport and security-related working group, contributing in HTTP, TLS, MASC, WIMSI, QUIC, and the likes. My background is started in service providers and internet availability, routing, MPLS, this kind of thing, but then moved more into security area, focusing a lot on data and privacy protection. And as my day job, I'm focusing a lot on things such as proxies, enterprise security, ZTNA, SSE, SASE. I also co-chair HPKey, which is slowly but surely sunsetting with its final deliverables. With that, we would like to highlight what is in scope for the seat and what is not in scope for seat. Nancy and I will be carefully observing all the contributions and making sure that we stay within our charter. So we are supposed to document a set of use cases. We do not have to produce an RFC as a result of use cases, but we're not prohibited from doing that by the charter if we decide to do so. The core deliverable for this working group is to develop mutual attestation in the TLS and TLS 1.3 to address those use cases and to leverage RAT's working group documents where relevant. Most importantly, what is not in scope for the SEAT working group, we're not here to define new authentication methods. Attestation is neither authentication nor authorization, so we need to be very clear of that. We're not modifying DTLS, TLS protocol, so we're not particularly modifying key schedule. This is something that TLS working group having fun with. We are not compromising on privacy or security properties, so attestation must not introduce any additional privacy or security issues. And for now, we are focusing just on TLS. In future, we may want, if there is enough appetite, expand the work beyond TLS and look at attestation when it's related to other protocols. But for the time being, we are very much focused on DTLS and TLS 1.3. And some organizational notes. For those who don't know, we have mailing list, and mailing list is the primary avenue for the discussion. So, for example, we're not going to adopt any documents during the session. This is something that we will be discussing on the mailing list, and all formal things will be happening via mailing list. And we have GitHub repo. We will be following RFC 8874, which recommends GitHub usage for working groups. Right now, this GitHub is quite empty because we don't have any working group documents just yet. But we expect at some point in near future that will change. With that, unless there are any questions, let's move to the first real item on the agenda. Ionut, let me share your slides. Or do you want to drive the slides?
I'm happy for you to drive the slides. Actually, first, can you hear me? Or
yes, we can hear you loud and clear.
Cool.
Okay, we're ready. So just tell me when to move to the next slide.
Sure. Right. So thanks everyone for joining this first presentation of the first incarnation of SEAT. So I want to give you an intro for this presentation into some work we've been doing to try to establish a scope for the SEAT working group in terms of use cases that we want to tackle, and also some properties that should help as a mental framework or as guidelines for developers of new protocols within this working group. Yeah, so next slide, please. So to begin with, I want to first focus on some background questions before we dive into the content. So I want to answer two major questions: why this document exists and what the purpose of the document is. So the document exists basically as a direct response to some questions that were raised during the XPAT BOF at IETF 123. Some questions regarding what exactly we're trying to solve here and what we're trying to enable. And also about the properties that we need fulfillment from either attestation or the secure channel protocols. And it also fulfills a SEAT charter milestone, as has already been described previously. And in terms of the purpose, we're essentially trying to build consensus for the scenarios that we're trying to build for, so the use cases, and we're trying to build a common set of requirements for SEAT protocol designs. So for now, it's for TLS, but maybe they're going to be used in the future for other protocols as well. Next slide, please. Right, so an overview of the actual IETF document. So we have two main sections, that's use cases and properties. So in terms of use cases, we identified 3 major areas that we think are relevant. So that would be confidential data collaboration, secure provisioning and high assurance operations, and also network infrastructure integrity. In terms of the properties, we found, let's say, roughly 3 categories of properties, each with a number of properties underneath. So for now, we have binding and freshness, which covers cryptographic bindings between various elements of the protocols, as well as attestation credential freshness. Another category is protocol mechanics, which covers negotiation and flexibility in how the mechanisms, the remote attestation and secure channel interact. And also we have another category for lifecycle and non-functional, so things like lifecycle of attestation credentials, privacy, and performance. Next slide, please. So I'm going to talk first a bit about each use case that we've discovered in a bit more detail. Next slide. Cool. So confidential data collaboration. The patterns that we've identified for this would be data clean rooms and secure multi-party computation. In the diagram on the right, I've mostly covered data clean rooms. And it's worth noting for this diagram and all following diagrams that the arrows are essentially pointing towards the tester, so the entity that needs to prove its trustworthiness to the other participant. So in the diagram here, you can see a bunch of data sources which could contain, for example, financial transaction information or healthcare data, who all want to pull their data together to be processed. But they don't want this data to be leaked to other participants or to anyone who's not authorized. So they want to verify the state of the confidential workload that they're submitting the data to. Then on the other side of this equation, you have users who want to make use of the results of that computation, but they want to make sure that they can trust whatever processing has been done. So they also want to verify the states of the confidential workloads and the processing that has been done. Next slide. Okay, another type of use case is secure provisioning and high assurance operation. And the patterns we found here are runtime secret provisioning and high assurance command execution. In the diagram, you can see a secret broker and then a workload owner connecting to a confidential workload. So the secret broker would want to provision that workload with things like cryptographic keys or passwords or any other secret information. But before it does that, obviously it needs to verify that it's talking to the correct workload, that the workload is configured properly, that its state is correct, things like that. On the other end, you have a workload or a device owner, let's say, who wants to send a command to either a workload or a device, but wants to first verify the state of that workload or device. Next slide. Okay, we also have network infrastructure integrity as another use case. And the pattern here would be essentially verification of the integrity of networking devices. And in the diagram, you can see a network orchestrator attempting to admit a new router to some networking estates. But before it does that, it wants to verify, let's say, the where that router has been provisioned, what kind of software it's running, whether it has up-to-date firmware, and that sort of level of detail. But at the same time, the network orchestrator itself might want to prove its state to a network administrator when that administrator wants to provision maybe new configuration or new credentials. So these are the use cases we've identified. Obviously, this isn't supposed to be exhaustive for now, and we're looking for feedback if you have other use cases that you think are relevant and we should cover here. Yes, so next slide. I'm going to talk a bit about properties as well, but it's worth noting that even though for now we're focusing on TLS, the properties that we've written down, at least for now in the document, are not meant to be specific to TLS. They're instead supposed to be more generic and to apply potentially in the future if we're trying to integrate remote attestation with other protocols like SSH or IKEv2 or things like that. So the first category of properties would be binding and freshness, for which we have a number of properties. So the first one, cryptographic binding to communication channel. This means that the attestation credential must be somehow bound to a secure channel session. And this would allow us to prevent relay attacks for the attestation credential, which means essentially we're preventing a man in the middle trying to convey some attestation credential that it got from a legitimate device, conveying it as if it's its own, and that represents its own state. Second, we have cryptographic binding to machine identifier, and this is intended to prevent diversion attacks. So if you know that you want to connect to a device or to a workload that's running in some specific estate, you shouldn't be able to be fooled by someone else who owns a similar device that they've managed to break into somewhere else, and just by rerouting the requests. So the attestation credentials would be bound to some identifier that's provided by the infrastructure provider. The first property here is attestation credential freshness. So attestation credentials are supposed to relay, essentially, in some cases at least, runtime information about the workload or the device that they're meant to represent. And obviously this means that the relaying party or whoever's looking to appraise the trustworthiness of that workload or device should have proof of the freshness of that attestation credential. And thus we want to prevent any replaying of stale credentials, or just want to make sure that the device is in the state that it's currently presenting attestation credential for. Next slide, please. Another category is protocol mechanics. So here we have things like negotiation and capability discovery. So peers have to somehow agree on whether they have support for remote attestation and on carrying on that protocol, and also any other relevant parameters that will be required for that protocol. Obviously, this enables interop and graceful fallback in case either of the two parties doesn't support this. We also want some sort of flexibility in terms of the attestation model. And for those who are not particularly familiar with RAT's terminology, so attesters or devices who aim to prove their trustworthiness produce two types of attestation credentials: either attestation evidence, which is the, let's say, raw form of information that's produced by a device about its state. And this would be checked in the background by the peer to verify its authenticity and to verify that it follows all the properties that the peer would require. The second type of credential would be attestation evidence. Attestation results, which act basically as a passport in a format of pre-checked evidence, attestation evidence, and hence those two names, background check and password models. And because these two models essentially offer different types of properties to the system that they're deployed in, we want to support both in case they would need to be deployed within these frameworks. And we also want to support interaction with peer authentication, with the existing peer authentication. So remote attestation must integrate with the existing mechanisms for authentication. So for example, for TLS, we want to support PKI-based authentication in the main TLS handshake. But also remote attestation may feature as the sole authentication method if it manages to fulfill all the security requirements that are put in place. Next slide, please. And the last category that we've covered so far is lifecycle and non-functional requirements. So here we have things like credential lifecycle management, and where we mean primarily attestation credential lifecycle management. As I've mentioned before, attestation credentials do represent the, let's say, runtime state or a live state of a device or a workload. And so the peer might want to do reattestation during long-lived connections. And ideally, it should be done without large performance penalties as far as it's possible. We also want to ensure that privacy is preserved as far as we can ensure that, given that attestation does tend to carry quite a lot of information about the device that's running on the other end, all the software that's running, and also configuration details. So this is going to be quite privacy invasive, but yeah, we should put as much care as possible into these protocols to make sure that we can preserve what we can. And in terms of performance and efficiency, obviously designs should not add prohibitive latencies or overheads, since this would probably kill any adoption. So these are properties that we've uncovered so far. Next slide, please. So a request from our side would be, so please read the drafts and provide any feedback either on the SEAT working group mailing list or GitHub repo. We do have some questions for the working group and other participants. Regarding the use cases, are these use cases representative? Or is there anything that we've missed? Anything that you'd be interested in reflecting in the draft? For the properties, is this the right level of abstraction? Do we cover everything that we need here? Yeah, and I know that Mark has already submitted some thoughts, so I'm here to listen to his thoughts if he has.
Do you want to
more
take
details.
questions now, Ionut?
Sure. Yeah, we can start with questions now.
Yeah. Okay. Go ahead, Mark.
All right. Well, thank you. I had a sort of back channel exchange with Yanut on this, and I would like you to consider the journey of a administrator of an endpoint in this TLS exchange, right? So say you own a server, and that server runs some workload, and then basically what you want to do is make sure that this workload attests in the manner that the seat wants to. Now, what generally happens is there are two parts to the workload. There is the hardware on which the workload runs, and then there is the workload itself. And typically in an organization, the workload is managed by the workload developer or some kind of vendor. And then the hardware is managed by either the organization's compute team, if you have like an on-premise data center, or your cloud service provider. And both of these are subject to upgrades, and both of them are subject to rollbacks in case the upgrade fails. And what you see often in RATs is that you get these attestation results, and these attestation results are very, very low level. So they talk about firmware versions, boot counts. They talk about, any number of things. But if you actually look at AR4SI draft, you take a look at generally what, it goes into the entity attestation token. These are very, very technical, very deep, and as a result, very fragile measurements. So now you are basically going to, and now say you have 100 clients connecting to your workload, and they all attest your workload, and they receive back this very complex, very detailed, very what I call propeller head information. And not only, but what's valid in terms of what constitutes a properly attested workload now has a bunch of claims from around the hardware and the firmware, so the hosting environment, what's effectively what you have to trust in order to trust what's inside the trust execution environment. And then you have to have similarly set of statements that you expect about the workload itself, right? So under your integration workloads, you should consider how to make the job of such an administrator easy. because if you don't, your solution, no matter how technically secure, is simply not going to get deployed because people cannot manage the complexity or there's too much fragility. So a typical scenario is I have hundreds of clients connecting to my workload and attempting to attest it. And if I need to roll out a firmware upgrade and say, well, now you need to require version with this hash as opposed to that hash, I would need to communicate that expectation to all of my clients, potentially hundreds of them. And if one of them misses the update, they can't connect anymore. And as a result, they're effectively experiencing an outage. And if they're experiencing an outage, then their experience is, okay, secure, but it is not allowing them to get work done. So this is this my main critique is that if you don't consider sort of the empathy of your relying party, you will have problems in production, and that's all I have at the moment.
Thanks, Mark. Yeah, I think this sounds reasonable, and I think some collaboration with Whimsy is probably unavoidable.
And this is not just Whimsy, right? So as a shameless plug, in the RATS meeting on Friday, my presentation is the last one, and it actually talks about one way of handling it. So I'm not flagging my way of handling it here. I'm simply saying, we do have a proposal. We should also discuss that. Maybe there is some common ground to be found. Maybe we can learn something from you, etc. So.
Yeah, I think we're open to discussing and figuring out exactly at what level to phrase some of these properties and how to frame them in a way that works for
right.
both.
Another thing is, anytime you ask anyone to change, your total addressable market shrinks. So if you can make something work with existing completely unmodified TLS stack, you will have a bigger deployment than if you require people to go and update some kind of software. So if at all possible, avoid.
Okay, so I'm going to stop here, Mark, because there's two more people on the queue.
Okay.
So my suggestion is just make sure that those get articulated, your concerns are articulated in the use cases as Ian is working on them.
Yeah.
Okay. Okay, next on the queue is Yuning. We can't hear you.
Yuning, it looks like your audio is not working. Hank, do you want to go ahead while Yuning is figuring out audio issues?
Giddy, you're not on the queue.
Can I add myself, or do I need to get on the IM to do it?
Do you want to let me go? Because we had locked the queue.
Go ahead. Hank left the queue, so you'll be the substitute.
Yeah, go ahead, Giddy.
Okay, thanks. Sorry about that. I'll get on the IM. Regarding properties, just a general question on how the working group will be addressing this as we go forward, because it's what Yonat has presented is a bit narrowing of the charter, in my opinion. For instance, I think draft facade TLS-attestation and approaches like that could still be considered in the context of this working group. But I believe that the firm requirement for cryptographic binding to the session key material would actually prevent that. So I'm wondering, how do we treat this document? Will the properties be narrow the scope of the work that can be considered in this working group?
So one thing to note is that we're essentially trying to, let's say, leave behind the TLS attestation draft, and we've pivoted towards the expat proposal primarily because of this. Well, not necessarily primarily, but partly because of this binding. And we have found, and at least from our perspective, it seems critical to have some sort of binding between the attestation and the secure channel, and obviously we can have a deeper conversation on what the security requirements and why this would be required, at least in our view. And actually, I think Usama might be talking about this in his presentation as well. But yeah, it's something we can discuss if you want. Just wanted to know that also the draft is.
Yes, and I understand. I understand the background behind why that draft is not being introduced to this working group. Yeah, I understand why that draft wasn't introduced to this working group. I've heard the discussion, but I don't. But I think it's premature to say that intra-handshake attestation is something that would be flat out rejected in the context
Okay,
of this working
we
group.
were pretty prescriptive, Gary, in trying to keep the charter narrow, so I will let our
It is
AD.
not in. This is not written in the charter. You can see it.
So I'll let our, Paul, are you speaking as an AD? Yeah, so he's right behind you.
Okay.
Paul Wouters, AD. So during the initial BOF, we were careful to not specify a solution specifically. So now we're a working group, we can talk about different solutions. And what I've noticed so far, at least, is that some of the core TLS people are like, use this solution so it doesn't affect anything TLS, so we don't have to follow your working group. This is not a strong recommendation for a certain type of solution. There's people here that have like preferences for various solutions. Before submitting a document to the AD to move forward, I would really like to be convinced that we picked a solution that is the best solution, and not a solution based on, I don't want to follow this working group, or I'm going to do it this way because it feels like it's going to be the least friction way forward, but it's not the most ideal solution. So I hope, and that's also why I really put the use cases as a milestone in the charter. Like, we really need to talk about the use cases and the support. So nothing is excluded at this point, and we should just have good, healthy conversations about good solutions, and then slowly migrate to, like, adopting drafts.
Okay, I just want to remind people, we had actually locked the queue. So on the queue is, so Yuning, I don't know if you've got your audio and voice on, because you're the last one on the queue.
Sorry, I can actually ask for her. Yeah, she sends me the question.
Okay, go ahead and ask.
Yeah, so
But
we do,
please be brief.
yeah, okay.
Make it
So
quick.
We
Yeah.
do AI agent security, and we have like a thought on the use case for it.
Can you
And-
need to speak louder.
Okay, and so the use case is actually surrounding like a dynamic and rapidly evolving application session regarding AI agents whose like models and tools and policies can change pretty unpredictably during a long-lived TLS connection, where we need a lightweight and in-band reattestation so peers can see the agent's current posture before high-impact operations. So if you think this use case is valid, we'd love to contribute with a draft on this and submit to the SEED group. So also we'd like to hear your points on that.
Sure, I think it's something we should discuss further.
Yeah, I think in the interest of time, it's best to take this to the list and see what's the appetite of broader community to adopt that use case. Now let's move on to our next agenda item. Usama, over to you.
Yeah, thanks very much. I'm Sama from TU Dresden, and I want to start by thanking my travel sponsors, Beck Jones, GenXT, Confidential Computing Consortium, and Teleport. As the AD rightly pointed out, so we are not excluding any possible solution at all. We want to have this discussion that which is the best solution, and that's one way of judging that is by doing the formal analysis. And based on the expert BOF, we have actually done a very thorough, extensive analysis of all the options that are available. And that's what I'm going to explain in this, what are the results, and some of that is work in progress. So my idea is to present the system model goals and the results, and then I have some details in the backup if that is required. A quick reminder from the BOF. Basically, I talked about the different possible solutions in the whole design space, pre, intra, and post. And I'm going to focus specifically on one use case that Jordan mentioned, that is the confidential computing use case. That is to say, the formal analysis that I will present will be specifically for these use cases and not applicable to other use cases. Because for formal analysis, we really have to scope what is the threat model, what is the system model, and we cannot do for, let's say, for all of the things at once. So others can be done on later in the stages, but we started with confidential computing. And the scenario is the TLS server as the RATS attester, which is to say the other, not to exclude the other use cases, meaning that the client as attester is also possible, mutual attestation is possible. We are just scoping it for the purposes of initial formal analysis. And the categories we have considered right now are the pre and intra. As already mentioned, they are not yet out of scope. And post handshake will have the same goals that I will present. So you're not presented the use cases at a high level. I will talk more technically about what they mean in terms of more formal thing that can be formalized. And for post handshake, that is the analysis is work in progress. At some point in time in the future, we will present the results when they are ready. System model is like this. On the left, you see the TLS client. On the right, that is the physical machine. That is basically the TLS server. And that is placed in some infrastructure provider, for instance, some cloud. And we assume that initially TLS client is provisioned with the public part of the attestation key. That is to say that it has reliably been provisioned with that. So we provide no guarantees or no, let's say, formal analysis on how that is done. That is an initial assumption to start with. And a subset of that physical machine will be trusted. So to say that is the hypervisor and other things which are in the physical machine part, which are not a part of the attester itself. And attester itself contains the confidential computing platform. And then the quoting agent, which is a general term for all the confidential computing technologies, like for Intel SGX and TDX, that will be the quoting enclave. And for ARM CCA, that will be the RMM. And then on top of that, that is the workload, the virtual machine, which contains the user data and the code. And that is the place where the network stack will terminate. That's what it is shown as VM1. And there will be an evidence corresponding to that with the state ST1, and the public key corresponding to that will be the pub EK1. And specifically, I want to emphasize there are consensus protocol applications in blockchains and so on, where that is necessary to ensure that even if enclave or a virtual machine is genuine, it does not interfere with the voting majority. It does not change or concurrently write to the process, which is actually to the file system and so on. So it's really important to identify which virtual machine we are talking about, and that's the private EK, which is identifying that specific VM. And since it's a cloud, let's say scenario, it's possible that there are other tenant VMs which are running on top of the same physical machine, and we still have to protect this VM that belongs to us from that other tenant's VMs. And that's why it's the boundary for the attester does not contain the other VMs. And with that, the physical machine will also have some identity. Jonat mentioned about this, that the infrastructure provider identity, infrastructure provider machine identity is very critical for preventing from a diversion attack. That is to say, for instance, for WhatsApp, if you are communicating via WhatsApp over the secure channel to the metadata center, you should actually be connecting with the, or you would like actually to be connected to metadata center and not to some other server in the somewhere in the world. So that's very, very important to actually have the provision to take care of this infrastructure provider identity. And that is represented here as IDS, and corresponding key is public LTK, the long-term key of that could be protected in some secure elements such as an HSM or a TPM. So we have two different certificates. Evidence can be in some other format, but just as a high-level idea, that's, let's say we have two certificates kind of which we have to transfer over to the client. And the goals that Jonat presented, I make them more refined in the form that I can actually reason about in some automated way. And they are integrity of evidence, freshness of evidence. Jonat already talked about it. Two more properties are that the attestation key and the ephemeral key. Attestation was for the quoting agent. Ephemeral was for the on top that the VM that belongs to us. Let's say the client does not connect to that connection which has these keys, the adversary controlled keys. So this is preventing that from happening. and otherwise the adversary can impersonate the virtual machine. Standard TLS properties, Appendix F.1 of 8446 BIS, so that server authentication should be maintained and no property of TLS should be violated. That is to say, adversary-owned keys should not be able to establish the connection. We want to preserve all the properties without any compromise of any of the properties. Composition goals, now we see two different layers, that is remote attestation goals, TLS goals. Composition are really combining the two. That is to say they are from both parameters. GC1 means that the binding evidence to a specific TLS connection that can be done at three different layers, which is the Diffie-Hellman GXY, handshake traffic secret of the client with which the handshake messages will be encrypted, and the third one, the application traffic secret of the client. I have a picture next to show that these are how these three levels actually relate to each other, and they are in an increasing order of information or the increasing level of binding. And agreement, the GC2 property says that both parameters from remote attestation side and TLS side should agree so that there is no relay attack or no downgrade attack. If a client wanted to have attestation, it should have attestation if supported by the server as well. With that, we already presented the results in the just before this session, thanks to the UFMRG chairs for managing this. And we have these results, which is to say that for pre and intra handshake, we take most popular solutions, which are interoperable RATLS. This is a proposed, this is a adopted project in the CCC Attestation SIG Confidential Computing Consortium, IRATLS, which is a improved version or to make Intel's RATLS more interoperable with the different solutions. And what they do here is that the evidence is pre-generated. That's why it's a pre-handshake attestation solution in the categories I showed. And you see a number of crosses that's showing that a number of properties are violated, including the freshness of evidence. And on the right side, or the last column, you basically see the intra-handshake attestation, which Giri was pointing to. And we have done analysis, and this is saying that the server authentication is properties violated, and it does not provide the required binding that we want to have. And I will explain you in the next slide what that exactly means. But that is to say that the TLS and composition properties are not satisfied for this kind of solution, and that's why we went ahead to kind of see what is the best possible solution we can have in intra, by doing all possible changes without ignoring even the charter which is agreed upon. So we really wanted to see what is the best level of guarantees we can have doing any possible extension, forgetting about the charter. And the best we could do is the solution 5, which is to say that we still cannot achieve the binding evidence to the application traffic secret of the client. And I will show you in the next slide why that is the case. The problem is that the application traffic secret of the client actually is a function of the finished message of the server. In order to include that in my evidence, I have to send that evidence afterwards of generating this ATSC. And in ATSC includes the log finished of the server, which means that it has to be between 2C and 2D. And in order to do that, that will then not be included, that evidence will not be included in the finished message. That is to say, there is an inherent paradox between this, that if I want to achieve that ATSC being included in the evidence, I will not have that included in the HMAC of the finished message. And that will then violate the integrity property that the two endpoints will not agree on the handshake transcript. And that is then going to violate another property. So whatever we do, the best we could try is that that violation of at least one property will still remain, even with doing any extension whatsoever, forgetting even about the charter. With that, I would like to summarize all the outcome of the formal analysis, which is that we need infrastructure provider identity to prevent diversion attacks. As Jonathan already mentioned, cryptographic binding of RA and TLS is very critical to avoid relay attacks. There were concerns mentioned in the BOF. So we have now a formal proof that relay attack cannot be avoided unless we have this. Pre and intra handshake are, Giri, you want to go now or? Okay, sure. So pre and intra are not suitable, as I have mentioned with the reasoning, formal reasoning. The paper is under submission in Asia CCS. We will have it. I'm also trying to finish over the preprint, which I will share with the working group, so to see all the reasoning that we have there. And one of the most, we believe this is one of the most challenging protocols in the whole IETF, reason being that is basically including a lot of architectural details in addition to the protocol itself. So it's not only a protocol verification, it's actually a combination of the protocol as well as the architectural details, because if you miss that architectural details, that the system model that I have shown you, if you change the system model, all the results will be very different. So we really need to take care of, and I have tried, like the authors have been meeting twice a week in order to make sure that every possible detail from the architecture level detail is taken care of. We have tried our best that every detail that we could include from our understanding is not missed. So we are requesting the feedback on the shared preprints, which are already shared, and we are inviting contributions from the working group to contribute to the formal analysis work. And post-handshake attestation, as I said, the draft which will be presented by Yaron next is under evaluation. And I mean, in the work in progress means from the formal perspective, of course, it's the protocol is also being designed in parallel. And the questions for discussion I have is the security goals that I presented from formal perspective, verifiability perspective. Do you see anything which is missing that should be added to these goals? And the second question I have for the working group is what level of abstraction does the working group want us to have the proofs on? So my questions are very, very specific to formal analysis rather than the protocol itself. Since I've been working on that, of course, Yaron will present the other part, implementation part. You can give your feedback there. And the third thing that I would like to discuss is the proposal for the lightweight TLS working group like FAT. I believe I would like to have some feedback from the experts on how we are doing on the formal analysis itself, rather than the whole working group just relying on me to produce something that you need to trust on. It would be great that some people or some experts can have a look at that, give us some feedback and say us, are we going in the right direction, or do we need some changes? Giri, please.
Thank you. Giridhar, if you can quickly, please.
And I want to thank all the co-authors and the contributors who have been contributing to all this work.
Yeah, thank you. By the way, first off, do not disagree with any of the conclusions in this. As you can see, my name is up there. But in getting back to my point in the previous discussion, I don't think this is necessarily an either or, pre-handshake, post-handshake. I do think that they're, particularly with the verifying relying party, they are presumably taking this attestation in the context of some action, whether it be authentication, access to resources, or anything like that. And the verifying relying party can actually balance what actions they take based on a intra-handshake attestation versus a post-handshake attestation where true binding with the session key material or the exported authenticator is possible. So I would like to see, Osama, maybe the formal analysis extended in that regard.
Sure.
To say what is the action the verifying relying party is taking, and whether the verifying relying party can actually mitigate that action based on a post-handshake attestation. So if it takes an early action based on the intra-handshake attestation, what kind of actions can it take that won't cause a serious security breach by the time it receives a post-handshake attestation and it realizes it cannot give any further authorization to the remote attester.
Okay, I'm going to put us back on time because we're not going to have enough time for the rest of the presentation. So, Giri, what I'm hearing you say is, there's two pieces to it. When Ionut talked about the use cases, you want to be able to capture the use cases that you wanted, but beyond the ones that he represented, which then may lead to the justification to the formal analysis. This is to say, I think we're jumping the gun a little bit on the formal analysis until we get alignment on the use cases that then drives us to, the proposals that we want to adopt. And we're going to do all of this through consensus.
So
Right.
maybe I can add one sentence to what Giri was proposing. Sure,
Just
just
make it
one.
quick.
So
Yeah.
quickly, the comment is that I think for the combination, I still need to do post-handshake evaluation, and then I can do the combination of intra and post. So Giri, that is under progress. So once we do post-handshake, we can do the combination as well.
I think that's fine. I'm just saying we formed the working group to adopt something.
Mhm.
And the something is the proposed way in which we're going to carry attestations in the TLS tunnel.
Sure.
And I think that has to be our priority.
Sure.
In
yeah.
order to do that, we have to get this group to align on the use cases that then leads us to that adoption.
Right, sure.
Okay. All right. So with that, let's move on to Joran.
Thank you, Nancy. I'm Yaron Sheffer. I'm only part of this group of authors, Thomas, Osama, Tiru, Hannes, and Yonot. And yes, this is the one draft that we believe is in line with the charter and and is in a reasonably advanced state. And I will talk through the details of the protocols as well as some of the open questions that remain. I think we've been through the context. So this combination of TLS authentication of one or two of the peers, along with attestation of one or both peers. And we are using a technology called exported authenticators in this draft, and I will obviously go into that. So some basics to start with. The draft is worded using RATS terminology and RATS building blocks, obviously the tester and verifier, but also evidence and attestation results as concrete pieces of data that go over the wire. We already mentioned the need to support both background check and passport mode. So both working with evidence and also with attestation results. The next slide will go into exported authenticators. And the core idea of the draft is to use these exported authenticators as the infrastructure, as the substrate for conveying the RATS related information. And at the end, what you get is a session-bound and integrity-protected attestation, as well as a normal TLS channel that you can use like you'd use any other TLS channel. So, RFC 9261 is exported authenticators. It's a generic technology that runs TLS-like payloads on top of an already established TLS channel. So you first run a full TLS handshake, and then you can use a subset of the TLS payloads, the TLS messages, and run them over this TLS channel to effect additional authentication, or in our case, attestation. We're reusing certificate requests, certificate and certificate verify, and adding an authenticator message that's similar to finish. There's also something called client certificate request, which is basically another variant of certificate request. So some of the TLS messages are reused, and the authenticator, so the finish-like thing, is bound to the TLS exporter, and this is why we call it exported authenticators. So what we are doing is essentially a profile of RFC 9261 for RATS attestation. And what we are doing is we're adding a new TLS extension that will only be used post-handshake, CMW attestation, and that supports both passport mode and background check, with no changes to the handshake. Now let's talk about CMW attestation. CMW is a conceptual message wrapper. Unfortunately, in my mind, RATS is all about conceptual wrappers, adding layers and layers of abstraction. So this is one of them, and it can basically encapsulate any RATS artifact. Among them are evidence and attestation result, but if you read the definition, eventually it can be endorsements and various other RATS pieces, but we will focus on evidence and attestation result here. Then we start by negotiating this transport of CMW attestation at the handshake level. That's still an open issue in the draft. There's a discussion whether we can use TLS flags to do it, yes or no. So still open. And then we use this CMW attestation as an extension to the certificate message that's run in the post-handshake exchange. So not your grandfather's certificate in the TLS handshake, but the second one that happens post-handshake. CMW attestation can be JSON or CBOR. So conceptual, and there's a question whether and how we want to negotiate the exact format of what's to be included in this extension. But the basic idea is to allow, if possible, both TLS peers to be completely agnostic to the RATS technology. So you connect to a verifier, the verifier knows all about what an evidence looks like and what it needs to contain, but you as the TLS peer and mostly as a TLS client don't need to know anything about it. And I'll follow with two example exchanges. One is in the passport model, and the second one is background check. So we start with the regular TLS handshake. Time passes. This is another open question. Do we want to allow for actual application traffic to be sent before the attestation stage, or maybe this time that passes is zero length. But anyway, after the handshake, the server sends an authenticator requests, which incorporates a client certificate request. The client now, this is the passport model, so the client needs to get itself an attestation result. So it sends its evidence, its collection of measurements to the verifier, to its local verifier, gets an attestation result, and this attestation result is now wrapped in a CMW attestation, wrapped in a certificate message, and sent along with certificate verify and the finished to the server. So this is Passport, where the client is responsible to get its attestation result. The background model, and here we have a separate attester, so a separate TEE on the client side. Again, TLS handshake, then an authenticator request. The client goes to its TEE, requests an evidence, so a set of measurements. This comes back to the client and is sent as is, wrapped in whatever, sent to the server. The server now takes this evidence, sends it to its friendly verifier, gets back an attestation result, and an actual thumbs up, thumbs down, should I trust this client. So both are currently supported by the protocol. Like we said, attestation happens after the TLS session keys are established. We prevent reuse. So we support freshness, non-spaced freshness of the evidence to prevent replay. And like we said, this should be transparent to applications that are using normal TLS APIs. Now, there's some complexity in the way the application is integrated or is using the TLS stack. If you want to support traffic after the TLS handshake completes, but before the attestation stage, that would add some complexity to the application. So this is part of that open question. I think we covered most of this, so I'll skip this slide. So to summarize, you get confidentiality and integrity normally from TLS. The post-handshake and the export, the integration with the exporter ensures that the RATS traffic is cryptographically bound to the TLS exchange. Nonces that I didn't describe in the diagrams, but that are included in the protocol to ensure freshness of the evidence, and various mitigations for your normal set of attacks. We will talk about our in-progress Rust implementation of this protocol, and lastly, call for. I would like to raise the question of whether we would like to go for adoption now. Like I said, this is currently the only solution on the table that's in line with the charter. However, there are still open questions. So I leave it to the chairs and the working group to decide on next steps for adoption, whether now or later. And that's it from me.
Okay, so before we do the call for adoption, are you going to do the poll? Okay, so we're going to do the poll. Who has actually read the draft? And those that are remote can respond since we're putting it on the poll. I should have clarified who are not the authors have read the draft. How many authors are there?
Well, I did not put my name, but I think we are
Well,
five or six.
Less than 8.
Yeah.
It's not a bad thing if the authors have read the document, right?
Yes.
I'm sometimes wondering with some documents whether the authors even know about the document they author.
Yes, this does happen. So I think it's now settled. So for the note takers, we have 10 yes, 16 no, and 1 who is not sure if read draft or not.
I think I would, given that we don't even have the use cases and alignment yet, Yaron, right? I think I would like to have this in the mail list to have some discussion both ways, and then we can do the call for adoption on the mail list. Okay.
Works for me.
So for those who have read it, please provide feedback on the mail list either way, positive or constructive comments. And then we can go from there. Okay?
Okay. We have one person in the
Okay.
queue.
Yeah.
I joined queue as individual participant, so no hats. One of properties of exported authenticators is that it's up to application to define any kind of structure to carry exported authenticator. It's not carried on TLS level, it's carried by the application. So application needs a way to encapsulate or signal the request and the exported authenticator. And right now, well, there are not that many, if any, applications that implement it yet. So HTTP working group, so for example, has been looking at secondary certs for quite a while and still not there yet. So do you have any specific protocols that use TLS where you expect this to be adopted sooner rather than later? Do you have any specific prototypes that use those standard protocols?
Good news is we will be talking about the hackathon and an actual implementation. The bad news is I'm personally not aware of other implementations of 9261, and maybe other people know. I don't know of other protocols that are proposing to use that.
Go ahead, Paul.
Paul Wouters, as purely as an individual. I want to point out that in the earlier session yesterday at TLS, there was a presentation about using PAKEs and adding round trips and changing things between having the regular session versus having additional round trips before you could use the session. And people were very uncomfortable having that state where your TLS session is up, but you cannot use it yet until some more TLS control plane messages have happened. And I think that is the problem of this draft too, right? And so in general, I hope we will get some discussion going where if there's really no other way we do this, but it seems that like if there's a way where we can have the handshake, when the handshake finishes, we're ready to use the connection, it is much friendlier to the application. So I would definitely hope we can do this. I'm not saying we can, I don't know.
I totally agree. There are some gnarly problems, including session resumption, that are actually pointed out in the draft. And yeah, there are some challenges.
All right, go ahead, Hannes.
Yeah, I was just replying to Paul's remark. I think this is less of an issue with this document compared to the intra-handshake. And that's also what is done with the bakes, because thereby you sort of delay the whole handshake itself. Here, of course, we still need to wait for the overall result to be finalized, but the initial handshake is already completed.
If you're in Lineker, you might want to get yourself on the queue.
I'm working on it.
Okay.
Jonathan.
Now I'm here.
Jonathan?
Oops, I'm in the wrong meeting. Someone else. This place is very confused at why I'm there.
Jonathan, we cannot hear you. If you're still working on your audio, Ionut, maybe you want to go first?
Sure. Yeah. So just to add to the same conversation, basically, we have looked at other or existing solutions that have not been standardized, who are deployed, and I think this sort of post handshake is also present. So obviously, people are comfortable using a TLS connection and then doing attestation on top of that. So this feels like in the same sort of ballpark. Thanks.
Jonathan, are you on now? You're muted.
My connection is apparently unstable. So the thing about exported authenticators, even though the draft, the RFC says to send the exported authenticator over the TLS channel, that's not a requirement of the security. I mean, it's a practical suggestion, but you could transmit the exported authenticator out of band. And so it doesn't actually affect what order. The order you do the operations doesn't actually affect anything. And so you could even, if you wanted, do some separate handshake protocol before the connection and then inject that state into the TLS connection. It's equivalent, right? Because it's a two-way binding.
Don't you need the exporter from the connection to put into the thing?
So if you want to use exported authenticators as defined, yes. But what was suggested at the TLS session was you do TLS connection 1, establish an exported authenticator, and then establish TLS connection 2, and that invoking state from the previous connection. And that gives you a TLS connection where both things have been confirmed before it's up.
Sure. I mean, to resume.
Go ahead.
So I'm just going to offload some state into my head, off my head into yours. So I don't have to send an email about this. You suggested in order to negotiate this, you should send an empty CMW attestation. What you actually should do is have have a request version, a response version. The request version is always empty, and the response version has a data in it. It's just a fine point, but that way you don't have the situation where like when you're requesting it in the certificate request, like there shouldn't be anything in there anyway. And so you should semantically not allow people to put anything in there as opposed to trusting them to put empty strings. So as I said, it's a fine point, but I just thought I'd mention it and get it out of my head.
Thank you.
Go ahead, Usama.
So very quickly to respond to Jonathan, I think that making two separate connections was not appreciated by some of the people. Even for one, like going for post handshake, there were already latency concerns that we are delaying the connections. So two connections, as you propose, might not be well appreciated in the confidential computing community. That's one of the targets that we have, or one of the main people who need this work. So we will definitely consider that solution, but I suspect that might not be well accepted or appreciated by the confidential computing community.
Should we just tell them the queue's done?
Let's take one more.
Okay. We're feeling generous today. Well, I mean, we lock the queue and you guys keep adding yourselves on the queue. So Stuart, please make it really quick because
I'll just highlight a discussion that's been going on in the chat with regard to whether or not you're allowed to use data prior to the completion of the attestation. Speaking from an aviation perspective, on the one hand, if you are going to maneuver based upon information that you have received from another aircraft, you want to be confident that that is accurate information, sent by a trustworthy transponder, et cetera, et cetera, et cetera. On the other hand, if that attestation is going to take some time and the information received suggests that we may be on a collision course, I may want to take that information under advisement, even if I don't immediately launch a dramatic maneuver.
On the third hand, if I were designing an aviation protocol, I would not use this one.
So sorry, Daniel. I think at this point, because we're negative 30 seconds. So can you please take it to the list?
Okay.
And because we need to have you report on the hackathon. Thanks, Jorn.
Okay.
Okay, now to the final part of our agenda, hackathon results. Ionut, over to you.
Thanks. I'll try to motor. Yeah, so I'm going to be talking a bit about running code for the draft that's just been presented. I'm going to talk about the hackathon and what we've been doing there, but first I'll start by presenting the overall code that we're working with. So can you please go to the next slide?
I passed you control.
Oh, okay. Let me see. Cool. Yeah, first I want to thank Peg Jones, who actually kickstarted this whole prototyping effort and provided most of the implementation. Fortunately, I think he didn't manage to join today, but yeah, thanks to Peg. Regarding this implementation, so obviously our main goal was to have some running code for the draft. So we started working towards the implementation and identifying any pain points and problems in the spec and to prepare for interop testing for when we'll have more than one implementation. And I think we already have some people willing to do a secondary implementation, but yeah, this is for the future to report. In terms of parents for this work in particular, it was focused on Rust, and basically it had exported authenticators based solutions on top of a quick connection as part of a test. And I've linked to it, and I think Yaron also linked from his slide. So state of implementation, it runs, it actually does a quick connection over which it exchanges first an authenticator request and then the actual authenticator and verifies it. And I think there's actually a test that does mutual attestation as well between the two peers. It does attestation gathering that is by default mocked, so anyone can just pull the code and run it and test and see if it all works. But it also has integration with Intel TDX, at least for now. Yeah, so the code is still work in progress, and we need to do more work to add other remote attestation backends. And we also do need to do some sort of integration with an actual TLS handshake underneath instead of quick. And if we look at what the code overview actually looks like, it has a bunch of TLS and exported authenticators paraphernalia. So on the TLS side, we have to do a fresh implementation of TLS messages that are needed for RC 9261, which Yaron mentioned. So certificate verify and finished, as well as the extensions that we need to be able to support remote attestation. These do encoding and decoding for the payloads. And I'm going to talk a bit about more on the next slide about why we needed to implement these. We also have implemented the certificate request on the authenticator construction, and also obviously remote attestation integration. So the ability to plug in that CMW into the certificate message extension, but also to collect the data, the attestation token that goes into the CMW message. The pain points we've uncovered. So first off, the Rust TLS ecosystem is a bit cramped, and it's the main reason why we had to implement a bunch of TLS specific things, because Rustls doesn't actually provide us all the necessary bits and bobs that are needed to build the authenticators in the first place. And it offers us no support for custom extensions, but at least it gave us enough functionality to be able to implement and parse things like ASM1, stuff like that. And second pain point, remote attestation software ecosystem is still very much a work in progress. So we have the CMW library, for example, which is also implemented by us, but which is in a work in progress state. So we've needed to make additions and change things. And also integration with other remote attestation backends with other attesters basically is difficult due to fragmentation of APIs. So we do have, for example, RATSD, which provides an easy API to consume that gives you whatever is present, attestation tokens that are present from the platform. But we don't really have a Rust client, so that's work for the future. So what we actually did during the hackathon, we provided an implementation that includes CMW. So now we package up the attestation token in a CMW, label it, and then depackage it on the other end and verify. And we did actually find one bug in the way we bind TLS and remote attestation. So this is a bug in the spec where we don't actually define very well how that binding should happen. There is already a keying material being exported in the form of the handshake context, I think it's called. But because that's not exactly earmarked for consumption for binding, we weren't exactly sure, and we'd require feedback from TLS experts or anyone who's more knowledgeable about 9261, whether it's acceptable to use that handshake context as a binder, or whether we need to define a new keying material exporter. Yeah, that's my update. So any questions? And if not, then I guess we can have open mic.
Jonathan?
Hopefully this will work first time. There we go. Could you make your final point again? What context were you trying to use in the exported authenticator?
So we have to have, like we've been discussing about some sort of binding, cryptographic binding between the TLS session or TLS state and remote attestation credential. So we'd need some sort of exported keying material that's used used in some way to be included in the attestation evidence that is created. We haven't defined that very well in the draft so far, but I know that 9261 offers I think it's called a handshake context, which basically defines some exported keying material. And the question was, is it possible or is it acceptable to use that as a binding mechanism, since it's defined essentially for a different use case, right? For use in certificate verify and in the finish message. Is it acceptable to use that for a binder, or do we have to limit the scope of its usage and define a new keying material exporter?
That's a very interesting question. I was the person who did the formal analysis of exported authenticators. I'm not sure. I'd have to see it written down, but I would guess you have to do a different context string.
Yeah, that's what I thought as well. Since that sort of doesn't necessarily limit you, but it seems to be very well targeted at specific use within the export authenticators framework. So we need something new.
Yeah, I think so.
Any other questions or comments? Should we close it? Any other business? Going once, going twice? All right, so do provide feedback on the mail list on the current proposed draft so that we can determine whether we're ready to do an adoption call.
And make sure you read the drafts before you provide feedback.
constructive feedback, please.
Thank you.
Enjoy you the rest of your week. Thank you, everyone. Not too bad. I was getting worried. It was like,